In this presentation, we'll examine how data can be read into and written out from C programs. The methods for doing this are flexible and therefore complicated, so we will present a slightly simplified view. They also make use of some more advanced features of C, so some of the points made will have to be taken on faith for now. The standard streams. In C programs, there are three files that are always opened at the beginning of the program and are automatically closed at the end of the program. These are called standard in, written stood in, standard out, written stood out, and standard error, written stood error. Normally, standard in is attached to the keyboard, so all user input is read from there. Standard out is attached to the console. This used to mean the terminal from which the user input was arriving, but is more complicated than this in modern circumstances. Usually it means the text window in which typing is happening. Standard error is the stream on which error messages are sent. This is usually the same as standard out, but the user can arrange for the text printed on standard error to go somewhere else, so error messages should be printed to standard error. In most command line operating systems, particularly Unix, the standard streams can be attached to other streams. This means that the user of a program can arrange for the contents of a file or the output of some other program to be sent to a program as if that data was coming from the keyboard, for example. This means we do not need to worry about writing programs that read data from files that we open or write data to them. We can simply use the keyboard and console. In fact, whenever possible, we should do so to allow the program's user the maximum flexibility. You can find out more about this from resources on Unix under Redirecting and Pipelines. Printf call. It's easiest to talk about outputting data from a program first, and easiest to experiment with this. In C, the function used to output data is printf, short for print formatted. In order to make use of this function, we must include the stdio header file. The functions and data structures in this library are part of the standard C library. The printf function is unusual in that it takes a variable number of parameters. From ANSI C, it has been possible for users to define such functions, but that is an advanced topic. The first parameter is a format string, describing exactly what is to be output and how it is to be formatted. All the basic C data types can be output, and they can be output in very precise formats. The format string defines how many parameters follow it. Older compilers did nothing to ensure that the correct number of parameters are supplied, leading to the potential for some serious and difficult to track down errors. But modern C compilers check that printf is being used correctly. Printf codes. Normal text in the format string is printed exactly as it appears in the format string. However, the string can contain conversion specifications. Conversion specifications are substituted with text that is the result of converting some primitive C data type into text. We can see the format string as a form that is filled in with the values of the variables that we want to print. Conversion specifications start with the %sign character. In the simplest case, this is followed by a single character, the code. This determines the type of data being printed. For example, %D indicates that an int value will be printed in decimal, whereas a %C indicates that a character will be printed. Some different characters indicate a format that will be used to print the data type. For example, $x indicates that an unsigned int will be printed in hexadecimal. $f indicates a double will be printed in a natural format, whereas $e denotes that a double will be printed in scientific notation. The format string must be followed by one extra variable name, or literal, for each conversion specification, and the variable or literal must be of the appropriate type. The variables must be in the same sequence they appear in the format string. This can cause problems with internationalization of messages in programs. If this is not the case, then the results will be unexpected and may cause logic errors in the program that will be hard to find. Printf modifiers. In order to provide more control over the format in which values can be printed, modifiers can be added to the conversion specification. These are placed between the % and the format character. The first modifier is the minimum field width. If the formatted data is shorter than this number of characters, the data will be padded appropriately to make it exactly this number of characters. Notice that if the formatted data is longer than the field length, the output will not be truncated to fit. Following the minimum field width may be a period. Following the period is a number indicating the precision of the formatted data. This determines the maximum number of characters to be printed. Data types will be truncated or rounded to fit. This is most useful for the E and F formats, where it denotes the number of digits to be printed after the decimal point. The final modifier that can be used changes the data type of the parameter supplied. In particular, the letter L indicates that a long or long double is going to be provided. The modifiers can be supplied as parameters if the asterisk is used instead of a number. In this case, integer values must be supplied in the list of parameters in the appropriate places. Presumably, these would be the names of variables. Printf flags. Furthermore, flags can be added prior to modifiers to indicate how the data will be padded to fit the field that is given in the modifiers and some other details. The negative sign indicates that the data should be left justified in the field. A positive sign indicates that the sign of the number should always be printed. A 0 indicates that zeros should be used to pad the data, whereas a space indicates that a space should be used if a sign is not printed. The hash mark indicates that an alternate formatting should be used. For example, this indicates that 0 and X should be printed if the output is in hexadecimal. Other rules apply to the printing of floating point formats. Printf example. In the first example, we are printing an int in decimal. The D is the conversion specification. The preceding 7 means that the number will be printed using at least 7 characters. More will obviously be used if needed. The 0 after the percentage sign means that the characters used to pad the number out to 7 characters will be zeros and not spaces. In the second example, an F has been used, indicating that we will be printing a floating point number. The period is used to separate the field width, which we haven't specified, from the number of decimal places. Since we have specified a 3 after the period, that means the number will be printed to exactly 3 decimal places. The plus sign at the beginning of the conversion specification indicates that the sign of the number should always be printed, even if it is positive. In the final example, the E in the conversion specification indicates that scientific notation should always be used. Reading from left to right, the 0 says that the number should be padded to the appropriate width on the left with zeros. The 16 specifies the minimum overall width of the number. The decimal point, followed by the 6, indicates that 6 decimal places should be printed. Since this is scientific notation, that means 7 significant places will be printed. The final E is what tells us that the scientific notation should always be used for printing this number. Scanf call. Input into a C program works in a very similar fashion to output. The function to call is scanf, for scan formatted. Any non-white space characters that are not part of a conversion specification are matched. In conversion specifications, the same characters are used as for printf. Notice that the parameters supplied to scanf must be pointers to the variable rather than simply the variable itself, unless the variable itself is a pointer or an array name. We will discuss these later. For now, we can just say that each variable's name should be preceded with the ampersand symbol. Clearly, the flags and many modifiers are unnecessary for scanf. However, the minimum field specifier can be used in restricting the number of characters read for a particular value. This is especially useful for strings, since we cannot ensure that strings in the input are restricted in length. This is known as a buffer overflow and is the source of many serious security problems in programs written in C. Whenever the %s conversion specification is used, a field width should be inserted to prevent buffer overflow problems. If the asterisk modifier is supplied, then the value is input but is not assigned to any of the parameters supplied. This can be useful if some of the input is to be ignored. Conclusion. Output from a C program can be achieved using the printf function. In this function, a format string is supplied which contains conversion specifications. For each conversion specification, a parameter must be supplied which will determine the value to be output. The value of this parameter must be of the appropriate type for the conversion specification. Modifiers and flags can be used to change the format of the value in the output. Input to a C program is achieved using the scanf function. In this function, conversion specifications are also supplied. For each of these, the address of a variable where the value will be read to must be supplied.